Alright, today we're going to cover scientific notation. For science, we use scientific notation in a way of expressing numbers that are very big or very small, which we end up working with very big and small numbers in chemistry. So what does a number look like in scientific notation? There's a couple of parts. Here would be an example, 5.02 times 10 to the fourth. So the 5.02 part, we refer to that as the factor. So the factor, we make a number that's between 1.0 and 9.9. The times 10 to part, the 4 is your exponent. So the 10 is referring to every time you move a decimal point, you change your number by a factor of 10. The exponent tells us how many times or places the decimal point was moved. Also, it tells us if you see that it's a positive number, that lets us know that the number you had before that was not in scientific notation, the number before was greater than 1. If you see the exponent is negative, that tells us that the number you had before that was not in scientific notation was less than 1. Okay, so examples of putting some numbers into scientific notation. For example, if I had 53,000, okay, so where is the decimal point? So technically, it's after the last zero. So technically it's right here. We don't usually write a decimal point all the time for a number like that, but technically the decimal point is there. So to put this into scientific notation, we need to move that decimal point. We want to end up with a factor between 1.0 and 9.9, which means we are going to have to move this decimal point to the left. So now we have to see how many times. We are going to have to move this. So we want a number between 1.0 and 9.9. So I'm going to move it between the 5 and the 3 because that'd be 5.3. Okay, so I've just moved it 1, 2, 3, 4 times. Now we have to figure out, will the exponent be positive or negative? Well, if I take a look at 53,000 and compare that to 1, that is bigger than 1. So therefore, we're going to have a positive exponent. So when we put all this information together, this 53,000 in scientific notation would be 5.3 times 10 to the fourth. That'd be your answer. For the next example, we have 0.0056. Okay, so where's the decimal point? Well, we can see it's right here. Okay, so now we have to figure out how to move the decimal point. So where are we going to move it? We need, again, a number between 1.0 and 9.9. Right now, 0.0056 is less than 1 here. So we have to move the decimal point. We're going to move it to the right. So we end up at 5.6. So we're going to go 1, 2, 3. So we just moved it 3 times to the right. So we have to see, will this number have a positive or negative 3? So if we look at the original number we had, 0.0056, and compare that to 1, this is less than 1. So therefore, we're going to have a negative exponent. So if we put all this information together, our answer would be 5.6 times 10 to the negative 3. Okay. So in the back right now, we're going to do some examples together of putting numbers into scientific notation. Okay. So 0.00041. Okay. So we need to move the decimal point. So we get a number between 1.0 and 9.9. So 4.1 would be between those two numbers. So our factor is going to be 4.1. So you're always going to have one digit that's not a 0 on the left of your decimal point. So 4.1 times 10, we moved it 1, 2, 3, 4 times. And now we have to think about if that's a positive or negative 4. So 0.00041 is less than 1. So therefore, this is going to be a negative 4. All right, next one. We have, let's see, this is like 50 million, okay? So the decimal points at the end here. We need, again, a number between 1.0 and 9.9. So I'm going to move this decimal point until I have one non-zero digit on the left of it. So that'd be the 5. So we're going to write 5.0. We moved the decimal point, so we changed our number by a factor of 10, and we moved it 1, 2, 3, 4, 5, 6, 7. So 7 times. So we have to think, is that a positive 7 or a negative 7? So if I look at 50 million, well, that is definitely bigger than 1. So therefore, this is going to be a positive 7. All right, next one, 0.012. So I need my factor to have be 1.0 to 9.9, so that would be 1.2. So again, some sort of digit that's not a 0 on the left of your decimal point, times 10. We moved it 1, 2 times, and now the last step, is this a positive or negative 2? So 0.012, that is less than 1, so this is a negative 2. 456.2. All right, so move this decimal point. We need to go to the left. 1, 2. So we're going to have 4.562 times 10. We moved it 1, 2 to the left. To see now if we have a positive 2 or negative 2 exponent, we look at 456.2. That is greater than 1, so that is a positive 2 exponent. 13,800 decimal point. We need to move that decimal point. So we have it one digit on the left of it that's not a 0. So that would be 1.38004 times 10. We moved it 1, 2, 3, 4 times. Then lastly, to see if the 4 is a positive or negative, 13,800.4 is greater than 1. So this is a positive 4 exponent. Last one is kind of a trick one, 4.5. It's already a factor, a number that's between 1.0 and 9.9, so we don't have to move the decimal point. Technically, if you wanted to put this in scientific notation, which usually you wouldn't, but this would be 4.5 times 10 to the 0, because you do not have to move the decimal point. All right, the last part is we're going to teach you how to actually type a number, a scientific notation number, in your calculator properly. Okay, so I'm going to show you on 2 different calculators, a graphing one and a scientific one. So we're going to work with the number 6.02 times 10 to the 23rd. So how would you type in a number like that in your calculator? Okay, so with a graphing calculator, the first thing you do is you type in the first part of the number. In this case, the factor, the 6.02 times 10 to the 23rd. Change the glare here. Okay. So we're going to go, I'm going to zoom out a little bit. Alright, so I'm going to type in 6.02. Okay. Now to get to the times 10 to part, you're not going to do the multiplication sign or the 10. We're going to use the exponent function, which we're going to hit the second button and use this function, the EE button. Okay, so for the graphing calculator, second button for mine is orange. And then the EE button is my comma button. I see a yellow like EE. So I'm going to press that, and you see one E pop up. So that means times 10 to. Okay, so that is the times 10 to part in this number. Now we're going to put the exponent, which in this case is 23. So you just type in the 23. And if you press enter, again, just kind of spits out that same number, 6.02 times 10 to the 23. All right, so for a scientific calculator, it's the same sort of deal, just the buttons look a little bit different. All right, so we're going to type in the factor, the 6.02 part, so 6.02. We're going to still use the second button, the EE. On this calculator, it's this purple or blue button. And then we want the EE function, which is above this x to the negative 1 button.